Exercise 16b, constant rate of change. Linear graphs have a constant rate of change. Now, a lot of people might think the word constant means they are flat, that they don't move, and that a constant means that there is no rate of change, there's nothing moving. No, a constant rate of change means it's the same rate of change for the entirety or for a section of that graph. So linear graphs have a constant rate of change, or in other words, the gradient does not change from one point to another. Distance time graphs are usually linear, and we use them, especially in the wonderful world of physics, to model and calculate average speeds. So if we've got this example here, a car travels from Bombay to Pune, a distance of 200 kilometers at a constant speed. The journey takes 150 minutes. Draw a distance time graph and calculate the speed. So when you see the speed, of course, you think your cars, think the speedometer of your bike or whatever the case might be. We've got kilometers. We'll definitely want kilometers per hour is the general appropriate speed unit, or alternatively meters per second is another one. We've got minutes. Minutes are gross. We'll try to turn that into something else that's more useful for us. Here I might suggest that we can either turn it into, we could probably either turn it to hours. If we turn it to hours, that's going to be 2 hours and 30 minutes. So that's 2.5 hours. So if we draw a distance time graph, the one thing to be aware of is knowing where the axes are going to be. So the distance part is the vertical axis. Looking all vertical over here. There we go. We've got a horizontal axis here. And so the car, so we'll put our units in here. Now, it doesn't matter if you put in seconds or hours, as long as you've got everything all lovely and calculated there. So I'm going to put this as T hours. And I'm going to suggest that this is distance in kilometers. And it's going to this distance, it's going for 200 kilometers, and it takes 2.5 hours. So if it takes 2.5 hours, we can go to some sort of effort here. We'll call that 1 hour, call it 2 hours. That would be 3 hours, so it's going to be about here. I've only got 1 point to really worry about, so let's call that 200. So this is 2.5, 200. And we'll draw a nice line here. A nice line would be nice over here. There we go. And we go. There we go. So what is the speed? So the speed for this one is going to be 200. So I remember this is y2 minus y1, x2 minus x1. So that's going to get me my speed. Remember, this is a gradient. Gradient is represented by m. 200 take away 0 over 2.5 take away 0, which is equal to 200 divided by 2.5. Now I'll go and make this probably more complicated than it needs to be, because I don't want to get out my calculator. But I'm going to treat that as a fraction, because that's what I do. 5 can go into that 4. So it should be 80 kilometers per hour. Find the rate of flow from the following taps in liters per minute. A tap that fills at 40-liter drum in 5 minutes. So the rate of flow, again, is another way of saying the rate of change, or the rate of the speed, I suppose you could say, the speed of filling. Now, it's given us exactly what units it wants. We don't need to draw a distance time graph. We could, if we like. There's our lovely distance time graph. We could draw it, or we could just do some lovely bits of calculating here. A tap which fills 40-liter drum in 5 minutes. We want liters per minute. So the distance here, or the rate of change, is simply going to be 40 liters divided by 5 minutes. So it's going to be 4 divided by 5, or 8 liters per minute. I would suggest if you're going to have to use minutes, use the abbreviation MIN, because M can mean other things and get very confusing with M equals being the gradient. So B, 600 litre tank in 12 minutes. Well, 600 divided by 12, it's minutes. 12 can go into 65 times, I hope. If I know my 12 times tables correctly, that should do. So that's going to be 50 litres per minute. Come on, give us a more challenging one. Oh, a tap which takes 17 minutes to fill a 200 litre tank. Fortunately, these can't be divided very nicely, and if this was a tech-free paper, you could leave the answer as is. You don't, please, and so many students like to ignore me when I say this, and probably because I'm a big old rambling man, but don't bother trying to do a mixed number. Nobody cares about mixed numbers. I don't want them. They are so unhelpful in this regard. Only very good for an estimate, and that's about it. You could actually just leave your answer like that. But if you're going to go and put that in a calculator, it should be about 11.8 litres per minute. But this answer is perfectly fine as it is. A tap which takes 17 minutes and 20 seconds to go and fill an 180 litre tank. Hurrah, some challenge here. So 17 minutes and 20 seconds. Well, what we can do here is we can find out how much of that is in seconds. So 20 over 60, so that's going to be a third. So that's a third of a minute. So 17 over 1 plus 1/3 is going to be equal to something horrendous. 52 over 3, so that's going to be minutes. 180 divided by, let's cut out the middleman, times by 3 over 52. Can we make this nicely divisible? That's not going to be. Well, we can at least get that into 90 over 26. Oh, it's divisible by 4, of course. So that's going to be 13, that's going to be 45. And so that's going to be 45 times 3, which is what? 45 times 2 is 90. 90 plus another 45 is 135 over 13. So the answer is 135 over 13 litres per minute, which if you've been asked for decimal places, you can say that is 1.04 litres per minute. But this answer is suitably fine for all things maths methods.